Hi guys, and welcome to another video. This video is one of my basic videos. I'm going to start doing a series of videos where they're just kind of basics, like they don't really necessarily link to a specific topic or anything, but they're just really good skills to have. So this is one of the videos I'm going to do. This is Surds. Surds, I guess you can say, is probably more used in maybe triangles and stuff like that. And it's just one of those things that teachers tend to kind of glide through. That definitely happened to me. I definitely through high school just had it glided through, and I'm kind of like, what is this? So this is a really good video just to kind of go through the basics. I'm going to go through a few basic questions as well, and this will be helpful if you're doing math methods in Western Australia. This is really helpful for trigonometry and using exact values, so that's where it comes into play if you're curious. So let's have a look, shall we? So on the screen at the moment, I've just got some basic rules. They're kind of similar to indices. Like indices have those, like, you know, the 6 index laws or however many laws you usually use. So index laws are, I think, this is kind of like the Surd laws, I suppose. These are just basic rules that you follow when trying to simplify surds. And surds are basically numbers that cannot be broken down anymore without it becoming a decimal. So exact values refer to numbers that are represented as whole numbers or as a fraction rather than as a decimal rounded up or down, because that tends to make it a little bit less accurate. So using exact values is really useful in that way. So this is used in that context of using exact values. So for example, root 5 is an example of a surd, because if you can't really break it down any further. We can't, if you do the square root of 5, you'll get 2.2 something. Like that's gonna have to be rounded. So we want to leave it as that exact answer. So that's times when you would use something like a surd. So this is an example of a surd. Square root 4, however, that's not a surd, because I can actually break that down to a whole number, because the square root of 4 is equal to 2, right? So that's where you can break it down. So it's kind of like when there's a square root involved that can't be broken down anymore. All right. And it's kind of manipulating times when you've got these surds and you've got lots of them and you want to break them down to kind of simplify them into a nicer way, if that makes sense. It's basically you've got a lot of surds, you want to simplify it and break it down, make it easier. All right. And we use these basic rules. So the first one here, we've got square root a plus square root of a is equal to 2a. So for example, for square root, or maybe I'll use a black just to clarify. So if you've got square root 5 plus a square root 5, this would be equal to 2 square root 5. That's my example there. For example, the next one is a square root of a times by square root of b is equal to square root of a times b. So remember, letters next to each other means they're multiplied. So for example, square root 5 plus square root of 7 is equal to square root of 5 times 7, or square root 35. Right? So then the next one here, we've got a divided by b. So we've got the square roots of those. So for example, square root 5 divided by square root of 7 is equal to the square root of 5 divided by 7. And the last one there we've got is square root a times square root a is equal to a. So this is in conjunction or linked with the indice laws. So if you recall, you might remember that square root of a is also equal to a to the power of a half. There's two ways you can write it. That's like the indice form. So if I wrote it like this, I can actually use my index law. So do you remember, like this? Oops, a plus n. So I can apply this index law here to this example here. So here I'm going to just basically add it up. So it's going to be a, because it's the same base number. So half plus a half. This is equal a to the power of 1, which is also equal to a. So that's how that comes about. So for example, square root 3, times by square root 3 is equal to just 3. And that's 100% cannot be confused with that first one where there's an add instead of the multiply. All right, so try not to get those confused. All right, so let's try to do some examples now. So this is related to all the surd stuff. So I'm using my surd laws that we've kind of covered previously. Let's try to actually use them to solve some questions. All right, so the first one here is quite straightforward. I've got two different surds. They're not the same. All I need to do is multiply them across. So what I'm going to do is I'm going to do 3 times 7, which is also the same as square root 21. Easy as that. Super simple. So the next one here is a bit more, it's kind of like if you can see any square root numbers or squared numbers, so that's like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So any of those kinds of numbers, so that means it's going to be 1, 4, 9, 16, 25, etc. If you see any of those numbers being square rooted, straight away simplify it. And if you see any numbers that can be broken down into those square numbers, break them down. So let's do that now. So first of all, I'm going to deal with this. I can actually break that down. Super easy. I'm going to break it down now. So square root of 4 is 2. So 12 times 2. And I can actually break this one down further. That's what I was trying to say earlier, is that if you've got a number that can be broken down into a squared number, for example, 4 times 3, I'm going to do that now. So I'm going to do square root of 4 times 3, and that's times by 2. And what's good about this is that I can break this up into 4 and 3 like that. So that's equal to 2 times square root 3 times by 2, which is equal to 4 root 3. All right. So just like that, let's do another one. So this one here now, I'm dealing with a few different things. So first of all, I've got this, which I can actually break down. So this is 4 times root 3 times by 3 times by root 3. Just keep that in mind. And one of our not index laws, but our surd laws is that if you're multiplying a root of the same number, that just forms a whole number. So that's just going to become 4 times 3 times 3. So that has just changed into the root, that 2 root 3's multiplied together just becomes that 3. All right, so it becomes 12 times 3, and so that becomes just 36. There we go. So I actually completely got rid of the surd altogether. All right, so let's do this one here. So this one here is simply, this is simply just adding them up. So what we've got here is 2 surds of the same number inside. So they've both got the 2. And remember, that does not just become 2. So 2 plus root 2 does not equal 2. That's only if they're multiplied. So otherwise, that just becomes 2 root 2. I'm just going to add 3. That rooted up. That's it. That's as simplified as it can go. Now, this very last one I want to go over is something that is very useful in a lot of times when I want to break it down. And I really don't like it when I have surds on the bottom. That makes things difficult. We always want to try and make sure that our surds are on the top of the fraction or become the numerator rather than the denominator. So we're going to rationalize it. So this is an irrational number. Basically, it's not a whole nice integer. So I want to actually change that and rationalize it, meaning making it on top and changing it and making that denominator something rational or something whole. Okay, so the way we do that is just by multiplying the top and the bottom by the surd that we see. So the surd in this case is root 5. So we want to multiply the top and the bottom by root 5. Okay, so I'm just going to do that right now like this. So whenever you're in a situation where you've got a surd on the bottom, don't leave it like this, rationalize the denominator. So multiply it by root 5 on top and bottom. So it's going to become like this. And you can see I've got that same situation again that I had earlier, where I'm multiplying 2 of those. And remember that this is the same as 3 times root 5 times by root 5. So that just breaks down to 3 times 5, which is 15. So that just rationally now, that becomes 2 root 5 over 15. So this is technically the same as this, but this one here is where I've rationalized the denominator. All right, so hopefully that was helpful. I did go through quite a few different examples of just using surds in general. So hopefully that was helpful. Please leave a comment if you have any other questions or anything like that. And please subscribe and like the video. Thanks, guys.